So, hey folks, this is me, Vishnu Jayadevan. I'm the host of this podcast. A lot of times I've decided something like, let's learn about the history first and now evolve accordingly. Because software engineering was not an hustle that happened overnight. It's an evolution that happened. And human evolved because code was the rule. That's how it is. And I was in an Azure Dev Day because Azure Developer Community Bangalore had organized one Azure Dev Day. And I was like, I went and sat in his talk and I was like the big fan of his, what he educated us. Like I love the fact that he evangelized history of software engineering more than saying us what a software engineer has to do. And that really gave me an insight about something beyond what I could ever imagine. And I was like, Vishnu sir is the right person for me to interview. And I was like, I'm here in DeepSource office from past four hours. And I'm being the fan of DeepSource right now. So it's an honor for me interviewing Vishnu sir and being live from the DeepSource office. And thanks to Noel for helping us and supporting us in recording this podcast. Means a lot, brother. And thank you so much, Vishnu sir, for being on my show. Means a lot.
Thank you very much.
I was a huge fan about what you evangelized that day. It's all about the history of software engineering and the way you explained it using Apollo 11, because that really was a game changer for me at that point of time. So I wanted to know, what was your journey as a student and your journey as a professional? Because I know for the fact there is a lot of insights hidden behind that journey to build the same Vishnu that we are seeing today. So I wanted to know that journey.
Correct. So my journey, I knew I was passionate about computer science. So my parents had a startup back in, I think, 2002, which was something like the Udemy or the education through computers, essentially. So we used to have a center. So I had access to like 4 computers, a Pentium 4 machine and 3 Celeron machines running IIS server on that. So I used to tinker with that a lot, started playing around with ActionScript a lot, because most of the software was built using Flash. So I started tinkering with that for some time, and then that's how my journey with computers started to be very. Looking back, that's how it started. Then I studied computer science. I joined a computer science degree in SRM University, one of the very famous colleges in South India. But in college, I kind of realized that I wanted to do more than just doing the academics and stuff. So in about my final year or something around that time, I started up a small startup. It was called Pastel on Canvas. It's probably buried in history right now, but we were doing an e-commerce company of sorts. Started writing code in PHP, etc. So I did not sit for the campus placements and stuff like that. And but I was very big into these events and hackathons and these community events that were happening in Bangalore. So I would travel down to Bangalore, attend a few of these events, and a recruiter from Exoto, which was my previous company. So he had seen me, and we got talking, and then I ended up working with Exoto and spent about 5 years there. And then I was looking for the next bigger challenge to solve. And then I kind of bumped into Sanket and Jay, and then that's how I'm here. So today, surprisingly, is my 2nd anniversary.
Congratulations
at
that.
work. Yes.
On your work anniversary.
Thanks a lot.
Yeah, that professional journey and the student's journey, it's a path.
Correct.
It's a journey that every student requires, and everybody wants that journey because it doesn't start or it doesn't end. Everybody is a student, everybody is a professional. So, journey as a cloud professional, because you saw cloud back in the days where it was not that famous in terms of what people go gaga about it now, right? People want everything on cloud because they know for the fact that there is a compliance and a governance that is coming up and a lot of things. So what was your journey as a cloud professional? How did this industry grow to what we are seeing today? Because what I saw in 2017, the same old TensorFlow is not the same old TensorFlow today. So I'm seeing an evolution in the same old technology that everybody wanted to get in. So I wanted to know about how the evolution happened, about what we are seeing today, and also what is the journey that you started with? Like, how did you start approaching problem statements in the cloud world?
So I think the cloud has always been there. I believe that, cloud as a concept. So the cloud vendors came up, like say your AWS or Google or Azure came up eventually recently. Like they became popular recently, but cloud has always been there. So back in the day, it would mean FTPing into a site and uploading your files, but that was also in a way cloud, right? So now I think my journey with like the main cloud services started in Exodal because we were using AWS for most of our infrastructure. So everything was on AWS. So we were tinkering around with that for the longest time. Out of 5 years, we were playing around with that for a long time. Yeah. So when I started off, it was the ecosystem had matured significantly. A lot of the services that you see today is also already there. So I've not been in the early phases of cloud where before AWS, I don't really know what happened. But in terms of my journey with the cloud, it has been AWS through and through. So we started most of it. So there was no Kubernetes at that time, or it was not popular at that time. So we were never using Kubernetes, but we were on EC2 missions. We were running RDS clusters. We were running huge RDS clusters, etc. So yeah, so it was a very normal journey for me there in terms of how I've experienced cloud. But a lot of things have changed. Right. For example, right now in DeepSource, we use GKE for most of our workloads. We use Kubernetes heavily, and nothing is out of Kubernetes except for the database, for example. But so that the main trend has been the adoption of Kubernetes. I think that's the main difference that I've seen, and to a large extent. So AWS, when I started off, it had like maybe like 20 services that was on cloud. Now pretty much everything is on cloud. So you're seeing new services coming up. Yeah.
Like, this is out of the topic that I just wanted to ask. Like, what is something that is still a prevailing problem statement in the industry today? Because to me, when I see that people are going crazy about the new technology, serverless is not the beginning. Serverless can also end because microservices were there. Microservices are still existing because everybody wants to know that, I read a very bad piece of code. It's not going to work there. It's going to cost me a lot. So now in DeepSource, it's all about code optimization and it's all about securitizing and testing it, because in DevSecOps, there's a new concept called a shift left, guard right. Because I think DeepSource as an organization is evolving based on that principle only. So I wanted to understand, like, what are some of the prevailing problem statements that are still there in organization that are yet to be solved in terms of process, people, culture, whatever it is. So how do you define it?
Yeah, so a lot of processes, a lot of problems still exist. So some of these problems are fundamental. Like, for example, how fast do you want your code from your IDE to go into production? That has always plagued us. Yes, serverless has come in, that has made some things easier, but it solves only a very minimal subset of problems. And serverless just means that somebody else is operating the server. It's essentially the same problem. So if you write bad code, you'll still end up with bad systems, bad performance, bad availability, all of these problems. So those fundamental problems still exist. Say reliability, availability, performance, all of these problems still exist. It has existed before. Things have gotten better. You have a lot more tools to work with, but the problems still exist. So that's where kind of shift left, for example, is basically to ensure that you don't hit your bad code or bad problems. Your problems don't hit production late in the cycle. Right.
Yeah, that's true, because when I see something that is coming up in the DevSecOps space, it's not like startups which are the tag called as DevSecOps is getting bought by great giants or something. It's all about that aspects that are just being covered there. It's something like, it's not about code coverage. It's not about building the dev culture. It's also about like getting the task done right.
Correct.
So in order to get some things done right, a Python developer can't be a Python developer for a longer run. A Java developer can't be a Java developer for a longer run. Like, there was JBoss back then, but today there's no JBoss. Like, nobody is so keen to adapt to it very often. Like, there are some technologies which are Stone Age. So I wanted to know how to keep up with the phase in which the technology is changing. You can explain it in terms of the software engineering way. I just love the fact that, I don't have the recording, but if you get that access to the slide, you will understand why I am so crazy about the talk that he just delivered in a Microsoft Reactor. So you can explain it in a software engineering way, how to keep up in the phase in which the technology is moving towards. Because you told me that you hated full stack developers, but you still work with a lot of full stack developers. So how to keep up the phase in which the technology is changing and how to evolve as a software engineer?
Yeah. So I think I just wanted to correct one mistake. I don't hate full stack developers. I want everybody to be full stack developers, but average full stack developers, but specialists in something.
Yep.
So, I would rather have people who are like a jack of one art, but jack of all arts, but master of at least one. Like,
Yeah.
right. So the T-shaped engineering concept, right? Like, so you want somebody to specialize in something, because when you look back at software for the last decades, right, or the last couple of decades, you will see that the fundamental problems have been the same. You still are limited by your physics. Right? At the end of the day, it's the physics that's governing most of it. You have limitations on how many transistors you can put on a chip. Right? You are limited by how electricity flows. You are limited by how the speed of light, for example. You're limited by, because speed of light controls how fast you can transfer internet data between 2 points on Earth. No matter how you solve it, that's the only way, unless we have new technology, maybe 20 or 50 years down the line, right, where you can, I don't know, have particles, controlled by spin, quantum physics.
Yeah.
Maybe it'll solve it. But at the end of the day, it's mostly the problems are very fundamental. The tools that you have, like the programming languages, the databases, all of them have evolved. But at the end of the day, it's again a fundamental problem that you need to solve. So what I kind of recommend, like junior engineers or freshers or people who are still in college, is to kind of focus on your fundamentals. You need to understand how systems work at a very fundamental level. Now, as you grow in your career, so you have to understand how things work under the hood. So you're working with, say, MongoDB, or you're working with, say, Postgres. How is data stored on disk, for example? That is something that you need to kind of dig deeper. And at the end of the day, you will realize a lot of these fundamentals are very common. And once you have a very firm grasp of that, picking up new technologies, etc., are essentially simple, because you break it down into a very fundamental problem of things written to disk or things transmitted over the wire. The problems are usually the same.
Got it. Yeah. Because I feel that fundamentals are like the best part about whatever you're learning. Because once you know what's the purpose of a Kubernetes within Docker container, you can really fetch out to the documentation, you can start learning. But how do you educate yourself? Because today there's so many resources, because DeepSource as an organization deals with many problem statements. Like how do you educate yourself in order to keep up with the phase in which the technology is changing? Because you were in AWS for 5 years, now we are working in GK and there's no relationship.
No, so even if you look at AWS and GCP, right? Like, so a lot of things are the same. Like, you're still running your Postgres or MySQL, it's still relational database. Your instances are still machines. So you understand your Linux concepts, or you understand your fundamentals about how that works. So in terms of educating myself, see, what I kind of believe is you learn only by doing. You don't learn if you go read. I don't believe in RTFM all the time. Yes, you need to read the manual before you ask someone. But at the end of the day, if you go and if you don't execute and try it out, you're not going to learn that. You're not, even if you just read any book, you will not really capture what is going on. You have to test and kind of, work on systems, like see it in action. That's how you learn. So my time here, most of the time I spend, so there's a significant amount of time that is solving a different breed of problems, which are like people related or project management, things like that. So that is a different problem that I'm learning now. Now, on the other side of the engineering side of it, I kind of get involved with, whenever there's a problem going on, I kind of sit together with an engineer, kind of ask him, hey, what are you doing? And then I'll go, when I have the free time, or when I'm working on free projects, I might try it out. The new technology comes up, I try it out. See, deploy a small service on production, see how that works. And yeah, so you kind of learn by doing is what I'm saying. Like, so no amount of tutorials or, companies offering, courses for huge sums of money, that's not going to help you in, like, when you're, because most problems in computer science are not, it's not for this question, there's no pattern to it.
Yeah.
So you're put in a situation where your database is crashing, you don't know why, right? You cannot really have a very templatized process of checking things out. Maybe there are a few things that you must check it out, but correlating that is something that you learn by doing and seeing it in action. So yeah, it's always learned by experience and kind of spending time understanding what is going on underneath all this.
Yep. Because you need to think the Toyota way. The Toyota production system probably is one of the most defining concepts that ever came in DevOps. So, of course, DeepSource is more towards the DevOps aspect, because they come in the beginning of the entire SDLC lifecycle. That's your code. It's all the testing, everything will obviously be happening, but code is what you do. But I wanted to understand your perspective in terms of the DevOps. Is DevOps a complex piece of puzzle in an organization? Because today we feel that there are different ways in which there's no one size fit all in the DevOps culture. There is different adaptation that's happening because some believe in open source, some don't believe in open source. There are techniques in which organizations are evolving. That means DeepSource has an amazing portfolio in terms of SAST strategies. And of course, like lot of code scans happen here and you get a lot of data here. So I wanted to know, is DevOps a complex piece of puzzle in an organization today? What do you feel about the way in which we are building tech? Because I know for sure there is no right way of building a tech, but according to you, what are some of the best practices that you feel should have existed in most of the organization, but they're not following it?
So the first thing I think a lot of small startups lack is in terms of testing. I'm a firm believer of unit tests. I need 100% unit tests. So I mostly code and go. So if I don't see 100% unit tests and services, I kind of get depressed. So that is one thing. So your testing strategy should be always solid because if you don't have 100% tests, there's no way to predict anything really. Now, so I think fair to say I'll break it down into the fundamentals. You have your observability where you see what is going on with your systems. So that is one important aspect of your DevOps cycle. Now your CI and the release system, right? The release engineering is another thing. So where, what is my timeline from the time I finish a feature or when I finish writing code for it to hit production? Reducing that and basically taking away a lot of grunt work that is involved for that with the engineers themselves and moving that and making it as fast as possible. So as soon as I finish my code, can I run the test? Am I comfortable enough to immediately deploy? And can this be automated? Now, that is one side of it. So your release engineering is one side. Now, on top of that is your infrastructure, right? So maintaining the state and making sure there's no drift within what is written. So, version controlling your infrastructure, etc. So that is another aspect of it. So I think these three, so observability, availability, reliability, that is one aspect that we at least focus on in terms of systems. And on the other side is the experience that your developers have within the organization. So I think these are the, two key areas that any company should focus on.
Yeah, because today it's a work from home culture. Many of them are working home. There is a chance that you can compromise anything. Like there are API keys that can be compromised. If you just can go and scan any of the mobile apps, probably there are some hundreds of secrets that are coming out. There are Git sprawl reports which are coming out with so many organizations are compromising so many of their credentials out there. So I wanted to know how much is an impact that a leadership in a developer. That means he need not have to be a product manager or anything, but in terms of he himself evolving as a person in an organization, how can the skills of leadership be adopted in him? Because a lot of times I'm a fan about people who are just in a leadership position. That means like they don't just impact you in terms of like just talking or paying you out. They actually give you beyond whatever is just being asked there. So how much is an impact of a leader in a company that can be affecting the culture of a company? Because what I see in DeepSource is like everybody is happy and everybody is happy about their entire. They can work from home, they can do anything, but they're very happy to work here. So I wanted to know what's an impact that a proper leadership can bring on the table for an organization.
Yeah, so I don't kind of believe in, like, I'm a very, strong proponent of, humble leadership as a humble servant as a, leadership strategy, right? Like, so you want to basically be the person who just empowers people. That's it. That's all the leader should be. You need to be able to enable the engineers in the team to kind of make progress. So the team that we've hired here, I think most of them, they're very young. They're very young. So probably some of them are younger than you. Some of them are still in college, but they're working at SE2s, SE3 levels primarily because they've worked extensively on their craft, just because they were passionate, not because anybody was paying them to do before they joined DeepSource. And we just started paying them for that. That's it. So what you as a leader needs to do, personally, in my opinion, is to basically enable these guys to work well. You advise them or guide them in the right direction and they'll do the rest of the work for you. Yeah.
Because to me, there's a part of me which says that, once I hear about an organization, it's all about that real IT culture that is always coming up, right?
Mm-hmm.
Because I do run a newsletter called it's ITS, DevSecOps for a reason, because I go research about Kubernetes, I go crazy about it. I thought it's just kubectl commands, but it's beyond it. So I wanted to know what's a real IT transformation that all organization needs to follow today and tomorrow, because a lot of times it's always that evolving culture that always comes in. It's never like the Prometheus fits every time. You need to evolve. So I wanted to know what's a real IT transformation that an organization needs to follow to the world that is tomorrow, that is always in the competition. And you can also give us some resources in how to leverage what you learn from chaos, because chaos is something that is being not evangelized that well, because SLAs are good. SLI and SLOs are not being talked today to that great extent. So I wanted to know how does an organization or a developer team evolve with respect to an IT transformation or a well-architected framework by experiencing a lot of learning that is coming from the chaos?
Yeah, so I kind of have this philosophy that I like, which is called anti-fragile systems, right? So if a system breaks, could be people, it could be infrastructure components, can it bounce back? How fast can it bounce back, right? And the next time the same incident happens or the same problem occurs, is it more resilient to that problem? So this is something that I think is fundamentally what most companies need to do. That you learn from your mistakes as fast as possible and make sure the next time that happens, you're at least 10% better than the last time, right? So that kind of adds up, and that compounds into basically making a system that very stable in terms of people as well, right? So if you have a particular problem that you're facing, or an engineer faces a problem personally in his career, whatever, you understand what went wrong. You look at it, you basically do an RCA, root cause analysis of that problem or a situation. It could be, root cause analysis can be not just for what went wrong in the database. It could be about what went wrong in this situation. How did we handle that particular problem, right? Now, can I come back stronger the next time I'm faced with this problem? Can I come back stronger? So that would mean processes needs to be kind of driven towards having these kind of systems where you make increments every time you basically use chaos to basically strengthen your systems.
Because I feel that, DeepSource has not just a platform, it's an amazing way in which you can scan your entire code. It's a kind of a tool, but it's also, I think, amazing strategy which DeepSource has put in, because it's open for the open source projects, but you have to just start paying them for the private projects on GitHub. So how are SAST, static application security testing strategies, changing in the world of DevSecOps? Because tools are evolving. There are ways in which process is coming, they are getting added. There are ways in which developer also is evolving, because back then, you were supposed to write a top to bottom, a Java stack. Like they were pestered to you write the front end in the Java, back end in the Java, everything has to be in Java. But today it's like everybody has an API and it's highly compromisable. That's what I think, because I just give this example of Kafka, because Kafka is an API and it really streams the data, but there is a high chance that if you have not configured it properly, there can be a chance that you have compromised your organization credential. So my question is, how is the SAST strategy changing the world of DevSecOps? Of course, DeepSource is an amazing tool. So tools are actually changing and they're getting adopted immensely in every platform. Like native applications require SAST, DAST, IaaS strategies today. So how are these guarding scenarios helping out developers in owning the security? Because I always talk developers own the security in an organization. So how are these tools like DeepSource or as the other SaaS tools helping developers adopt to a situation where they own the security strategies?
Yeah, so tools like DeepSource play about 25% of your total security, resolution success rate is basically driven by tools like DeepSource, right? So things that we can detect from the source code, that we detect. But things like, or say, for example, your Kubernetes file has issues, or like you said, like if you have secrets in your code, that we can detect. We can detect and report. So that is your first line of defense. That's your most important line of defense. If somebody goes and hard codes a credential in the code, there's nothing, you can't pretty much do anything. Once it is out in the world, it's out in the world, right? So that is your 25%, which is, I would say, like a very critical piece of your puzzle. You solve that. And it's a very, tools like DeepSource makes it super simple. It basically blocks your PR the moment you see a security issue. It'll block it, right? So we analyze for the OWASP top 10 and SAST 25 risks within the code. Now the other side of it is configuration management and process-wise problems. So a lot of this would be caught by manual reviews, etc. Who knows the system? That is something that a dynamic system cannot, like a program could understand or solve. Now, code reviews is going to play a big part in it, where the code reviewer knows this is potentially a risk. So you spend enough time looking at the security. So when you're code reviewing, you're not looking just at the code and the way it's written. It's not about styles, etc. You use DeepSource for that, but you look at what could be a threat vector, right? You evaluate the APIs. Are they okay? Should this API have these access? Should this user have access to this API? Those kind of things you have to it always is going to involve a human, because that is something that is not very objective. It's very subjective and based on the system. Now, on top of that is basically your other side of tools, right? Your IDS systems, intrusion detection systems. You have image scanning, like the real-time security incident notification, your network monitoring, making sure, say for example, a lot of companies have been hit by security issues where they're running Bitcoin mining, etc. Right? So things like that you can only identify with some sort of a system which looks at the packets and figures out, hey, there's a fingerprint there, I can block. So yeah, so tools, so different layers of the tool. So the first part is your source code security. You make sure that you're not shipping any code with any sort of security risks that you know of, right? That can be objectively caught. Now on top of that is the other side. You're basically guarding the systems from these things, and you, like I said, you be resilient. You detect an issue. You see an issue, you make it harder.
Because to me, once I see it evolving as TLC process or anything, it changes to me, because I've seen companies which wanted to go from Java to the Flutter, because at that point of time, probably there was so many compromised credentials were there. And I was really puzzled, because why do they really want to change the stack? But I learned something called as anti-patterns, and anti-patterns really help us in evolving the architecture. But how can an organization today leverage an anti-pattern in order to evolve in the game of architecture? Because to me, when I see Netflix is known for chaos engineering, the chaos monkey part. And the way you explained software engineering that day was more towards, there needs to be an error, because the first bug was a morph in a triode. And that was named as a bug. But today it's different, because it's the tools which are coming up and saying that, we found out that there is a very bad practice going on here. So how to fix it? So I wanted to know how an anti-pattern can make sure that an organization's architecture and the practices evolve on a philosophical as well as a technical note.
Architectural anti-patterns, it's a different breed of problems, right? So you need to understand, there are obvious things like you shouldn't have a SPOF. You shouldn't have any single blind failures in your systems. Or DNS is always an issue. I had to say that. And on top of that, you have things, you need to have a load balancer, your typical architecture best practices. That is one side of it. Now, on the other side of it are, tools like DeepSource, which kind of ensures you do not have anti-patterns or bug risks in your code. Right? You basically shift left. Because any bug that you catch earlier in the cycle is about 1 by 25th or 1 by 50 at the cost of fixing. So it's easier to fix a bug earlier in the cycle than it is, once it's on production.
Redemption decreases when you shift.
Exactly. So there's a lot of statistics available for that. So what you need to do is you make sure. So you're talking about a company moving from Java to Flutter just to get out of anti-patterns, etc. Right? So personally, I feel like Java is a very solid language. So is PHP. I know PHP developers get a lot of hate, but I like PHP. You can write good compliant good code in PHP, right? Yeah. So you solve those problems using a static analysis tool like DeepSource. Now, static analysis can also help you, kind of look at infrastructure as code, right? Because that is again code. So we can now go through your Kubernetes files and your manifest and your Terraform files and kind of detect problems with that, where there are recommendations against this. So there are anti-patterns that you can detect from IAC. So that is something, again, a static analyzer kind of comes in and plays a role. So that is something that DeepSource as well supports. We support Terraform and Kubernetes and Shell, etc. Right? So you analyze the source code at a very early stage in the cycle before it becomes infrastructure. Now, once it is an infrastructure, that's a different problem altogether, where you, at least at this point, you need an architect or somebody who understands systems well to kind of go and solve that. But hopefully, if enough people keep adopting infrastructure as code, that'll go away. And all of this can be automated away as code analysis, is what I kind of believe in. Not completely backed by facts, but I think, everything infrastructure related can be converted into code eventually, and you will start seeing, tests, and you'll have unit tests for code. So we have unit tests for some of our images. For example, some of our build pipelines, we have unit tests, which kind of builds an image, verifies everything works fine, and so once all of this goes and becomes IAC, you will start seeing all of these problems being solved, right? Static analysis can run and kind of figure out if there are anti-patterns or security issues within your infrastructure configuration. Now you can also have, change, you can have versioning of infrastructure, etc. So that is, I think, the direction where, you need to kind of solve infrastructure with.
Yeah, like sometimes, we push the environment variables into the GitHub, and probably if it's public, it's compromised already, folks. You can't help that, because that's one of the patterns which I always say, because back then when I listened to some DevOps guy who was saying that, that some stupid guy just pushed the environment variables into the GitHub, and there are 500 VMs which are already created using that entire credential that he just compromised. So I think there is a chance that misconfigurations can happen. So how are tools like DeepSource, probably any SAST tools, actually helping in getting rid of those misconfigurations? Because tools don't mean anything until they really solve a problem. So I wanted to know, how are these patterns analyzed? How are the patterns made available as a tool, and they can scan off and they just give you the...
Correct. So say, for example, if somebody pushes a credential into GitHub, it's compromised. Now, what you can do is be alerted the moment that happens, right? So there are two aspects of solving this, right? One is making sure as soon as a secret goes into production, you get an alert, or you say there's an issue, which DeepSource has something called a secrets analyzer, which automatically detects as soon as it finds an identifiable secret in code, it gives you an alert, or it basically raises an alarm in the PR. Now that is one side of it. On the other side of it is your typical least privilege policy, right? Developers should not have access to any production code.
Because there's policy as code, governance as code as well.
Correct. So, and in general, so for us, developers don't have access to any of the credentials, right? Your credentials are safely kept and locked away inside a system, which keywords essentially, yes. So your developers should not have access to your production system. At most of the time, your developer should have access to metrics about how many instances are running, what is happening with those instances. You can look at the state, but you should never be able to look into the data of the user. So that is particularly important for us because we maintain source code of other users. So we kind of try to make sure that we are not accessing the source code of the users or using that internally as well, right? We don't want to store source code and mine data or something like that. So we want to make sure when an analysis or, when we start analyzing source code, we don't store that data, like the source files. We store the recommendations that we have, which we have to show in the UI. So that is one thing, but we never store any source code within our data so that our developers cannot go and someday go look at, hey, what is this customer doing? So we don't have that system. So we don't store it intentionally. So those kind of security practices, most of that is governance and how you manage your security posturing within the company. Right? So yeah, so
that's the thing, because most of the time it's also about like organization having the trust on you, right? There can be a Linux which had vulnerability for 12 years and it got solved later on. Mm-hmm. There are instances of that as well. So that's it. You have the right practices, you have the right configurations in hand. You can evolve at any given point of time.
Yeah. So no system is ever going to be completely risk-free, right? You'll always have risks. All you can do is to make sure you harden it as much as possible. I mean, I'm sure, FBI has been hacked at some point, right? Or the NSA has been hacked. It could be a person who is just stealing stuff. So you can never 100% eliminate like all risks from a system because it's a computer, it's connected.
Human is the weakest link.
Exactly. So what you do is you enforce security as much as you can, right? You enforce compliance tools, for example, right? Say, for example, DeepSource just recently launched a new feature where you can look at all the OWASP and SAST 25 issues. You can basically see, okay, your code has these many issues, and you can get an alert. Or when your number of security incidents is greater than X, you can basically block your PRs, for example. So that is something that, that is your first line of defense. Now you enforce as much as possible. Like I said, you harden your infrastructure, you harden your source code, you make sure your secrets, you're not giving out secrets to anyone. You use key management systems like Vault or things like that to basically make sure you're not exposing any secrets to the world. So so it's a big set of processes that you would have to kind of do, but there's no way to 100% guarantee that your system is going to be foolproof.
It's a complex puzzle. You need to solve it according to the needs of you can't just go ahead and solve everything. So last question from my side, it's more of security, but you were a security person because you were more of an guy who told me that if you have used Zomato at one point of time, you have probably have experienced some of the code that have pushed to the production. So working in production is a great deal. By the way, I've never worked on too much of a production issue or something. Probably I've written some Flutter apps, API here and there. I've done some bug bounty as well. So I was thinking about the greater the organization, the greater the funding. I feel that your credentials are out there in the world somewhere down the line. I know people who have done just Google Docs and they have exposed organization secrets.
Humans are bound to make mistakes.
Yep.
You will, you enforce your processes and policies in such a way that you make sure that risk, the surface area, the human surface area is reduced as well, right? So that means you limit or you audit the number of people who have access to production data or credentials or even access to like key management systems who can access, auditing those. So if somebody goes and maliciously does something, who's to blame or who's to be held accountable for that. So you have to ensure these two processes. But on the systems level, I think the first line of defense again is a source code analysis, kind of understanding, see if there are secrets or vulnerabilities or risks that are already there. Detect that early before you let it to.
Yeah, because I wanted to know how can a tool like DeepSource help in the cybersecurity practices? Because you were never a cybersecurity person, but yet you are still solving amazing problems with the DeepSource as well. Because you're part of the team which sees a lot of vulnerabilities in the code. So how can a bounty hunter or a cybersecurity professional leverage tools like DeepSource or any SaaS tools as well?
So DeepSource isn't or static analysis tools are not geared towards that. It's more into the static analysis of code
in a production.
Yeah. So a bounty hunter has to do things a little manually. You'll have to have tools and tool suits.
Because some bounty hunters don't even use any tools. They just go through the source codes and they just do that.
Yeah. So I don't think static analysis. So there are things that you can do. Like for example, there is something called taint analysis, making sure the input or so whenever there's an input into the system, you can actually trace the path of that input and see if it ends up in any vulnerable parts of the code. Like for example, SQL injection, for example, if you can figure out this variable is being passed around and being executed at this point, and there is a SQL injection vulnerability. So that is something static analysis can detect, right? So there are things that static analysis can do, which is something that we are as well focusing on. So that is one side of it. So that is something that basically removes the need for a pen tester to kind of go and figure out some of these, at least the basic vulnerabilities. So a lot of things you cannot figure out because it happens only in production, because it's not related to code or it's the way the system is configured, etc., or the firewall is not configured correctly. So some of these things you cannot predict because that changes based on system to system or the organization to organization, what ports to expose, what APIs to export, what credentials to give. That is something that is controlled by the company, right? By the organization. It's not controlled by, you cannot detect the yes or no between whether this is right or whether this is not. Whether if there are three roles like a user, admin, and guest. So static analysis tool cannot predict, okay, in this company, okay, guests should only have access to these. That is something that a penetration tester will have to go and look at what is happening and kind of find out.
Yeah, like last question. Sorry for that. What's a litmus test according to you for a great developer culture that is coming up in an organization? And what's that litmus test that you have for a great developer that he's going to be? Like, it need not have to be something like that should happen the next month. You can evolve as a great developer, but it takes time. So, what's your litmus test? Because I'm a huge fan of.
For a developer, so what we look forward to, or when I do interviews or when I'm building my team, what I look forward to are people who can do or doesn't hesitate doing things more than what his task is, right? I want engineers who are passionate about software engineering in general as a craft, right? So craft is something that you can teach someone. So I want engineers to be in a way that they're curious about software engineering in general. And they're not just limited by what are we working on today or what are we working on this sprint or this week, right? If you see a problem, if you're working with a database like SQL or Mongo or Aerospike or Redis, does that developer spend enough time to try to understand how is that system built? Right? You are easy looking at the fundamentals of how a system is being built, right? So is he curious enough? That is a litmus test. Now, because I don't believe in a lot of the route learning that happens, right? You mug up a few questions and come up to an interview and, kind of say, okay, I know this question, I know how to solve it, right? So that's why I kind of don't like these pattern-based questions, right? Reverse,
Just say
find
no if
quickly.
you don't know.
Exactly. So I don't. That's why. So our interview process is also kind of geared towards that. We don't make you do your data structures, your typical data structures algorithms questions primarily because we don't think that is a very good. See, it is a good bar racer of sort. I mean, it's basically a filter. It's a low pass filter essentially. But at the level we are operating in, or how our engineering team is operating in, that is not going to cut it. So we look at, have they done enough things. Open source is a very, very good indicator of what he is capable of his curiosity and passion. So that is something that I would look at. And the ability, so our interview questions are also systems based. Like, so you would be asked to write a library or a package during a pair programming round where you can look at Google, figure it out so easy, kind of spending time to understand what is going on. So that is our kind of process as to how we hire. But I would say curiosity would be the main thing for me. The drive to go and look at what's happening besides the work that you're doing on a daily basis, and and the enthusiasm. And I mean, I don't want people who just comes to office and finishes a task and goes back home. I'm not saying that you should work 10 hours or 12 hours a day. Even if you spend 5 hours, spend it reading and understanding it. Kind of be curious and passionate about what is going on in software engineering, what is happening underneath this. Even if it doesn't affect me, that is a culture that we can't take, right? So most of our engineers, they contribute. So a lot of our product features, they're driven by engineers, right? So
Yep.
because our tool is, we dog food everything that we built. So our engineers know when an issue is kind of off, right? Or functionality is off. They come and kind of, or they try to raise a PR, or they go and talk to another person. Hey, do you think this is a problem and can we fix it? So that kind of curiosity and enthusiasm and kind of working cross-functional and having developing a passion for that, that is the biggest thing for an engineer. That's your level one. And now the level two is basically having, confidence and, your typical things like, are you able to communicate well, etc. So that again, that's only secondary. The primary thing is he curious? Can he learn? Can he learn on his own, like with enough? So if I give him enough resources, if I give him enough people to talk to, can he go and figure things out? So that's what we look for.
That's amazing. That's amazing. Guys, if you want to really be a software engineer, don't worry. Just go start with your C program. Just evolve. Once you join an organization, evolve with that organization. I think probably Vishnu sir's talk was more towards the history of it. But today we are not talking complete history of it. But we are just giving you that insights which can really give you and set your standards high, because there's no one person fits in an entire company or something. It's all about that continuous hustle. If you're good at communicating, you are 90% a good software engineer and a bug bounty hunter. You need not have to do an awesome thing. You just can go back to the fundamentals. Just do that and Amazing insights were shared. I think this is what you require. You need not have to design a complex system, but you just have to design a fundamental understanding about what is this organization evolving towards. And then you start evolving. I think thank you so much, sir. Thank you so much for such great insights. I'll share the slides if possible. Please do go through that. And of course, if you want to really learn what is DeepSource all about, just go Google them. DeepSource, amazing projects are coming up. You can contribute in their open source platform as well in the GitHub. That's it, folks. Thank you so much. Any ending notes?
Please reach out to us on deepsource.io/jobs. We're looking to hire a lot of great engineers in the team, and we're solving a very tough engineering problem. So, thanks a lot.
Amazing team. If you want to evolve as a software engineer, or else if you want to evolve as a person, go ahead, apply for jobs here. Amazing culture here. Amazing coffee, by the way. Just come here, enjoy, evolve as an engineer. That's it, folks. Thank you so much for tuning in, and we'll see you again with another DeepSource person.